Okay, in this video, I'm going to talk about key-based containers. So this is in part going to be a recap, but there's also going to be some new stuff here. So because in the first assignment 0, and the first modules where you were introduced to data structuring and pandas, you were already introduced to different types of containers. In particular, you worked quite a bit with sequential containers, but you were also introduced to key-based containers. But we're going to focus on these key-based containers in this module before we eventually proceed and introduce the JSON format for holding structured data. Okay, so what are containers? Which have we seen? So we have seen a range of sequential containers. We have worked quite a bit with lists, which we can modify, meaning that they are mutable. So we can basically go in and just change a specific element in a list without having to create a new list. And these are useful for collecting data on the go. Then we have also touched upon tuples, which are immutable, meaning that we cannot really change the elements after initial assignment. So we cannot go in and just change a specific element without having to create a completely new object. And because tuples can do less things, basically they're also faster, which is in many cases the reason why we want to work with them. And then we've also introduced arrays, which are mutable in content but immutable in size, and they are, as we've seen, great for data analysis. Okay, we have also touched upon some non-sequential containers. In particular, we have already been working quite a bit with dictionaries, which are accessed by keys. And then we actually not talked very much about sets. In sets, elements are unique and they're not ordered. And for this reason, we cannot access specific elements in the set. So we can really think of this container as being very similar to a set in a very mathematical sense. It's just a range of elements that are fundamentally unordered. Okay, how did we make a container which is accessed by arbitrary keys? So this is going to be a recap here. So we can do that by using a dictionary. So a simple way of constructing a dictionary is the following here. So here I'm creating a dictionary that I call myDict that has 4 observations in it. So associated with each of these observations, there is a key. In this case, the key is a name of a lecturer in this course, and then the value that's associated with this key is the position of that lecturer. Okay. So for instance, if I want to, in this case, know what my own position is, I can write myDict and then refer to Joachim, the key, and then what I get in return is PhD fellow, which is my position. So this is basically how dictionaries work. We can also create dictionaries or fill out dictionaries in a loop. So we can consider the following example here, where first I create an empty dictionary that we want to fill with different values. And then I loop over values going from 0 to 100, excluding 100. And then what I do here is I create first a key. So I call the keys cube and then each of these values that we are looping over. And then the value that's associated with these keys is this again, these values that we're looping over raised to the power of 3. So for instance, if I want to know what 10 raised to the power of 3 is, I can just access the value associated with 10 by typing my new dict and then cube 10, and what I get out of it is 1000, which is 10 raised to the power of 3. So that's another way of filling a dictionary with values. Okay, so another way of creating dictionaries is to create a dictionary from 2 associated lists. And this is something that we can do with the zip function, as I will demonstrate in this example here. So consider the following code here. So first I create a keys list that has 3 elements, A, B, and C. Then I also create an associated value list with 3 elements, 2, 3, and 4. And now I want to create a dictionary out of these 2 lists where the keys list represents my keys and the values list represents my values. So how do I do this? So first I use a zip function on keys and values, and then I wrap it in a list and I create key value pairs. What I get out of it is the following thing here. So you can see I get a list that has 3 elements, and each element there is a tuple with a key and with a value. So you can see already here, this really looks a lot like a dictionary. It isn't a dictionary, but it has the exact same structure. So in order to create an actual dictionary out of this, I just input key value pairs into dict, and then I get my dict2. And then when I print it, I can see that this is in fact now a dictionary. So it has the same structure as here, but it's now a dictionary, and I can verify that by fetching, for instance, the value associated with A, and you can see that I get a value of 2. So this is another way of creating a dictionary. You can use this zip function. Okay, so finally, does there exist a file format for each easy storage of containers? Yes, fortunately that does, and this is a JSON file format. So JSON is a standard format for basically sending data by HTTP requests between different web browsers and other applications. So the JSON file format, it can store both lists and it can store dictionaries. And luckily, the syntax is, when you work with JSON, is basically the same as when you work with Python lists and dictionaries. The only difference is these quotation marks, as you can see in this example. So why is JSON useful? So one reason why it's useful is that it's a quite standard format, as I mentioned, that looks exactly like Python. Another advantage when we work with JSON is that JSON is extremely flexible for holding complicated structures of data. So you can basically hold a complicated structure of dictionaries without dictionary, whereas dictionaries within other dictionaries and so forth. And that's also something that you're going to see in this module. Okay. There is also another extension to spatial data called GeoJSON, but that's not something that we're going to work with in this course, but it's something that you can maybe work with in more advanced data science courses.